thank Recursion for hosting us and giving us food. So thanks, Recursion. Give them a round of applause. We love it when people give us food. That's why I come to these things. It's not because I'm in charge. For announcements, we'll start off with the normal. Is anybody hiring or looking for jobs? I'm not hiring or looking. So no, anybody else? I kind of expected that. Go ahead.
We're hiring a engineer at my company, but I have no idea about the details.
Okay.
But if you hit me up very much sacred on LinkedIn, I can probably send you. See me dating, it's 5 years ago. Yeah. Yeah.
Okay. Aaron's company's hiring.
Quicklease.com. I'm gonna give some people some leases. Run some data.
That was cool.
Sean and I work there. We're awesome.
There you go. Next week is the MLOps meetup, and they're talking about not this cool topic. They're talking about AI in CRMs, and the speaker used to work at Salesforce. I think this is a way cooler topic. It looks like doing machine learning with SQL, and I'm still confused how on earth you can train a machine learning model with SQL. So that's why I'm here. If you didn't know, this meetup is a part of the Forge Utah Foundation. We've got a bunch of meetups we run. We've got a great Slack community. You can join the community. Just go to forgeutah.tech. There's a button right in the middle. You click it, you join Slack. You hang out with all us cool people. And we can talk about the DuckDB UI all day, every day, because that's the only thing I care about. But I haven't even used it, but I'm really excited about it, guys. It's cool. Yeah, I don't think I have any other announcements, so we'll turn the time over to Jeff. Jeff volunteered to speak. He had exactly 1 month of notice, and we're super excited to have him. Let's give him a round of applause.
All right, can you guys hear me? You can't hear me?
Well, just make it.
Okay, hello?
Turn your sound up.
Can you hear me better? Can you hear me any better back there? Okay, a little bit. All right, so today we are going to talk about machine learning in SQL, because ML in SQL is like a great acronym. You know, we need as many letters all tacked together as possible. So I just want to kind of maybe get to know you guys a little bit so I can understand everyone. So who in here would consider themselves like a DBA, more like a database administrator? Okay, any just data engineers? Everybody else? Anybody else is kind of a different role that I wouldn't know about? Programmer, okay. Sorry? Compilers, okay. Very interesting. Thanks for coming. Yeah, so I want to talk to you guys a little bit about this, and to set the stage. So I was in machine learning and data analytics about like 6 years ago, really heavy. And then I went and did a stint at like a company being more in like leadership. And now I've come back and I'm doing like data warehousing. So this is my, you know, return tour that I'm doing to see if what's changed. And this has been one of the topics that's been particularly interesting for me, because I kind of have been trying to watch this over several years. And I think there's some great developments in here that will be interesting for people. So once again, I'm going to plug that there's like an interactive part to this, or you guys could take this home. I'll just demonstrate it. It seems like it might be too hard to get everybody set up, but you would need Docker to get this going. And then you would need to be able to pull this image down. And what this image has in it is a Postgres database, as well as some extensions, a machine learning extension that's enabled on that called Postgres ML. And then it has a UI, so you can kind of play around with it It's not as cool as DuckDB, I guess, but I mean, maybe? No? Okay. Um, got to plug DuckDB like a bunch of times. How many do we have? Just kidding. Okay. So, and if you don't want to like type this whole thing in, you can go to this GitHub link and you can go to the self-hosted section and you'd be able to just pull it there. You don't have to type all the things in. Okay, cool. So just a little bit about me. I'm Jeff. I'm a dad. This is my little girl who currently thinks she's a dinosaur. So we wake up to roars and go to bed to roars every morning. I like to ski. I like history, music, anyways. Yeah, so just to kind of go back and talk a little bit about where this presentation came from. So about 5-6 years ago, I was working at an e-commerce company, and that company came to me and my team, and they said, "We're spending almost $1 million a month on advertising. Which one of our customers are actually worth spending money on?" Right? And so that was the initial question that was given to us. And so we thought, okay, we can take our data, we can go back in time, and then we can try to predict if they bought anything in the next 6 months, right? We can kind of play that over and over. And so we started down the task. And so I want to talk to you about kind of how the state of things were back in the day. And we'll kind of compare this with where I think we could have done it better if we would have used machine learning and SQL. So the first thing that we did is we went and we pulled the data, right? So we thought, where's all this data? There's customer data, there's orders data, there's returns, there's reviews, and we just kind of gathered it all in like a big SQL query, right? So we got some kind of a data set. And then immediately we pulled that data locally, right? Which does that ring any bells or cause any alarms for anybody here? Because if you haven't done that, or if that doesn't cause any alarms, you're at a small company. If it does cause alarms, you're at a big company. So pull the data locally because we don't want to go over the network all the time, right? And then we take the data that's there locally and we stick it in a pandas data frame, right? So all of the SQL people here know that like a query result set is like a data frame, right? It's kind of the same thing. We just kind of did it again, but we did it in Python, but it's kind of the same thing, right? And then we prepped and cleaned it. Of course, we did it in Python in a place where, we can try to, figure out missing values and do different things. And now that script lives over here away from the data, right? And then we had to use the scikit-learn library because who doesn't use scikit-learn, right? It's awesome. And so we pulled scikit-learn in our notebook, and then we argued about the train test split, even though that's kind of already been like figured out, or it would have been fine to not really do this. Does this sound like anybody else here? Yes? Okay, I'm seeing a lot of nods. So, and then we said, well, let's try these different algorithms. And the machine learning engineer, he steps up and he's like, well, we could do XGBoost because that solves everything, right? And then everybody else keeps arguing. And then we finally figure the right model out, right? And then we get the model, we train it, hyperparameter optimization, and then we dump it to a file called pickle, right? Because you got to pickle the files, otherwise they won't taste good. But like pickle is very, I think, tightly coupled to Python, right? It's not something that other things are really going to know. So now we're kind of still in Python world. And then we need to host that model file somewhere, right? Because at the end of the day, a model file is just a bunch of numbers, right? It's these weights that are being serialized out that can be reloaded back in. And we host the file. And then at the very end, guess what we have to do? Run all of this and put it back into the database, right? So I guess steps 2 through right before this one, we're all brought into a Python environment. And now we're going to put the results right back into the database, right next to our customer, where we're going to say, spend more money, spend less money, right? Or VIP status, or 1 through 5. Does that make sense? Okay. And then this model starts taking off and people are like, hey, we really want to know this in real time. So now we take the model, host it somewhere. Somebody's going to try to put it in a Lambda. Somebody else is going to try to put it somewhere else, right? And eventually we're going to want to update this new model. And guess what's going to happen then? The data that was initially sourced, nobody has version control of that data. So we can't actually run the same algorithm on it and really feel confident that we did what we were supposed to do, right? Does anybody feel this like very deeply? No? Yes? Okay, good. Maybe. I saw a little laugh back there. Yeah. And so I'm not saying that this is a good way to do it. I'm saying this is how we did do it. And so I want to talk and kind of walk across these and look at the problems with this particular approach. So obviously pulling the data close to you makes it faster, but you're going to have a data governance problem there, right? You shouldn't be able to pull that onto your machine and then walk out the door with it to go home and have all of your customer data right there, right? Loading data into a pandas data frame. I mean, you're going to have to transfer it and then load it back into memory. Make sure you have enough memory on your local machine. Preparing data is not reproducible. The prep steps you did, if you pulled it out, put it in a Jupyter notebook, it is if you use Jupyter notebooks correctly, but you could maybe do that better. You have to learn scikit-learn to be able to do machine learning. And I don't think everybody should have to, or pandas and what an ND array is and all these weird gotchas that you're going to run into. The train test split, it's going to cause problems. People are going to want different algorithms, right? We've talked about these as we went along. And you're going to have to figure out how you host all these problems. Okay, cool. So what if we could make this better, right? That's what we're driving about. This is the before, and now we're going to talk about machine learning in SQL and how it can solve some of these problems. So with machine learning in SQL, instead of pulling the data out into a local file and getting it there, what if instead we use the SQL permissions, which your DBAs and everybody have really thought through, and just leave the data in there where it started? Does that make sense? And then instead of loading it into a data frame, let's just not. And then instead of prepping and cleaning and creating like a view of your data that's pulled locally or stored in S3 as a version number, let's just create a view that we could use over and over again, assuming the data underlying doesn't change, right? Because views are fun like that. And then this is showing you a little bit of the future, but what if you could just call kind of like a schema, a function that says train, right? And you could point an sorry, point a particular algorithm at the data set and then train it. And then what if instead of arguing about test train splits, we just said use the best practices, or I can override it if I really want to. And all these algorithms, we probably want to have a lot of them. And as far as pickling a file, if we're just going to pickle a file and it's just going to be some kind of representation of numerics, could we use like a vector or something in the databases? And so as you can see, like that's what this PGML does. It just stores it right in the database. So you don't need to read it back out or manage it differently. It's going to be controlled. You're going to be able to have permissions on that particular field or that particular table. So only certain people can see the models. And then you could just call PGML predict, and you could insert these predictions right into the database based on a prediction function. And then you could integrate any web app with it, so you don't have to like push it into a cloud vendor or figure out how to host it yourself. You could just hold it in a Postgres, which any library can really interact with. And then when you want to update it, it could just automatically promote it with a database flag of like, hey, this is the promoted model. Does that make sense? So what do you guys think about this world? Does this sound like a good world, a bad world, or a mixed world?
I was expecting fewer steps.
It's true. Yes.
I'm excited for it, right? Like,
Yeah.
I want to learn how to do this in just SQL.
Yeah.
I just didn't want you made that one sound like it was too many steps, and now they're the same different steps. So
Yeah. Well, it'll look better.
okay.
Yeah. This is for effect. It's for effect. All right. So yeah, so this is kind of the idea behind it. And I want to just jump into a quick demo. So we'll jump into, there's lots of ML and SQL type projects out there. And for this one part in the presentation, I might have you guys look around and try to look for your database that you use and for any machine learning tools that are already built, because I think a lot of people just don't know. But my demo will be using PGML or Postgres ML because Postgres is awesome. And it's an extension. Yeah, so you can just, any Postgres, you can pull on this extension and you have machine learning. So let me give you a high level overview of what they've done with Postgres ML. They've taken scikit-learn, they've taken XGBoost, they've taken some other libraries, rewrote them into Rust because that's cool, right? And we've got to do that. And then now that they're there, you can access them natively inside of the runtime in SQL. So we will go ahead and start with a demo. So the first demo, I'm going to open this up, which is that link. I think I will. Gosh, sorry. Zoom is taking over the top of my screen. Can you guys still see that? Cool. Okay, so this is the Postgres ML kind of thing I put on the screen before. So what it is Postgres with the extensions installed. Those extensions then have XGBoost and everything installed underneath that. And so we're just going to go through a simple example. So one of the toy data sets that's out there is a tumor detection data set. So what this data set is it's for a binary classification, right? So binary classification is simply yes or no, or the famous hot dog, not hot dog, if you guys are fans of that show, Silicon Valley show. Yes. And, or like, oh, true or false, right? So you're just trying to find out if they are or they're not, right? So churn, whether or not someone churned, it's either a true or a false. And there's a set of problems out there which are called classification problems in machine learning. And there's other problems which are trying to predict a number, and those are called regression problems. You're trying to find out the price of something, right? So predicting the stock market would be like a price. Predicting whether or not they churned would be like a classification, right? Putting them in buckets versus putting a number to it. So let me go ahead and walk you through this particular example. So this data set, it's a breast cancer data set that is actually going to be loaded from scikit-learn's internals, if you look at how the extension works. But when we run it, it's going to load it and create a table for us called PGML. So it put it on the PGML schema, and it created the breast cancer data set, and it put 569 rows. So this isn't a massive data set, right? It's just to play around and to learn machine learning. I was joking on the way over here with my brother. I was like, my goal is to, these data engineers, they're like the bass guitar players, right? Or the drummers. Like they do all of the work and they keep everything moving. And then the like machine learning engineers get up there and they're the singers. And so we're trying to upstage them and just do it all in the database. So anyways, it landed better with him. But he's a database guy. So. All right, so then we're going to just look at some of the data. So this is going to hit that table that was been loaded, and it's just going to pull in some of the data, and you'll see it's just different numbers. And then on the far side over here, we have a field called malignant, right? Which is bad, which means cancer, right? And so we then can look at the data set that's been loaded, and we can do this thing right here called pgml.train. And so what it does is it creates this project name, and that's kind of like a key for your all of your models that you're going to run. They fall under this project. And we're going to give it a class or a task of classification, which is like a type, right? We're going to tell it which data set to go and hit inside of the database. And then we're going to have it go and run the prediction. So going back, we didn't have to pull it out. We didn't have to put it in Python. We didn't have to fight with Anaconda for like forever and then get to this state. So we can just run this right here, and it's going to go and run and create a classification. So you noticed it used a very just a simple linear classification. So it tried to use lines to figure out what's going on. And so now how can we actually predict things? So if you look, so that was that first step we kind of talked about. You can train a classifier. It took the classifier, put it in the models in your database. So you can go to pgml.models and you can see the model now. And you can see those weights that it just created. They're stored in your database. And then you can reference those again later. So now that that's stored, we can reference that project. And then we can pass in an array of new data, which we're going to select from the actual test data set itself. And then we're going to add a prediction column on the side. Does that make sense? So we're taking the whole data frame and we're just adding one. So when I run that, you'll see malignant was what it actually was, and our prediction is on the right. So trues should map with ones, falses should map with zeros. And you can see it did a pretty good job. So that's really powerful. And at this point, if you wanted to, you could spin up an API and just hit the Postgres database and start doing that same thing, getting these predictions without needing to host a model somewhere else. No pickling involved. And we're off to the races. So I'll just continue on a little bit more. So this is kind of the next really powerful part. So before I was, back when I was doing a lot of machine learning, there was a company called Data Robot. I don't know if anybody's heard of Data Robot, but they came around and they were like, you need to pay Data Robot because we'll make your machine learning a lot faster. And what they were pitching was the idea that you could like give them a data set and they would just run every permutation of machine learning model on lots of clusters and everything. And then they would eventually do the hyperparameter optimization for you. And their whole thought was like, we'll just save you time in this whole machine learning process. And so what we're going to demonstrate next is basically, instead of guessing or trying to know which algorithm you need to use, as long as you know the optimization function you're trying to get or the score, you can just run all of them that are available in scikit-learn against the data set right here. And then you would be able to compare their scores at the very end. Does that make sense? So in here, it's going to train all of these different models, right? That's essentially what it's doing. So if you look down here, it's going to put out a bunch of data. And what I want you to see first is you'll notice also that as the algorithms ran, it told you what algorithm it was running. And then it told you whether or not it chose to deploy that for you. So remember how we talked about how all these models, eventually you want to like improve them. And if you do, you want to deploy them quickly. So this one, as long as the score beats the previous one, it just promotes it to production. Go ahead. I don't know. Can you ask me more passive aggressively? No, I'm just kidding. It's a type of algorithm. Somebody here probably knows, but yeah, there's all these different ones that it ran, right? So it just did data robot in essentially in the database. And these algorithms now, I think because they've been tuned, and I know there's a lot that's gone into scikit-learn for as far as optimizations, like these can run pretty efficiently on normal hardware. So we did all of data robot in just my little Docker container right there. And then at the very end, what we can do is we can actually see how all of these different algorithms scored, what their F1 score was, what their precision and their recall is. And these are specific metrics that can be used to determine which algorithm is doing well and should be promoted. So does that kind of make sense to everybody, what it's doing? Yeah, go ahead.
That's kind of cut off for specific metrics for it to decide which models to use? Or, because you said like it uses a score cutoff, what's the score?
So you can tell it based on the classification what score you're trying to achieve, and you can promote based on that score. Yeah. No, it's not here. Not in this particular toy, but you can tweak on the project which one you want to be the winning score. Does that make sense? Cool. So yeah, so that's kind of the at least one of the initial kind of run through. As you can kind of see, there's other projects in here. There's other models. Oh yeah, so this was the breast cancer, and you can see all of those different models that it trained, and it has a cool graphic to show you like what were the scores, so you could compare them. And then at that point, it's already promoted the ones as well that it saw as being the best. So we can go and look at some more notebooks, and I think this one's pretty cool. I'll just run through it really quick. This is diabetes. I just want to show you at the very end. So it creates a diabetes data set. We have a prediction score we're trying to get. We can, in this situation, we're trying to predict, it's more of a regression problem. So we're trying to pick a number instead of like a bucket. And so in this one, we'll run it. And then we can predict on different people what the score is for their chance of diabetes or whatever. And then we keep going. This is going to show you the top performing or what it got as far as its score, not very good. Then we'll just like throw the whole kitchen sink at it, every model that's in scikit-learn, plus XGBoost and some other ensembles. And you can see it doing Ridge was better than that first one. And then the next one it ran was Lasso algorithm, and it didn't do better, so it was not deployed. And then Lasso least angle was deployed. And then you can kind of see as it keeps going down which ones it tried. And so, oh, sorry. At the very end, another thing that's pretty cool that people spend a lot of time on is now that you've tried all of these, there's going to be a winner. And we want to take that winner and like really try to hone it in, which is through hyperparameter optimization. And so this shows an example of running hyperparameter optimization. And so this will try a grid search of all of these different options of depth, number of estimators, learning rate, and it will run all of them. And then it will show you which one was better, if I did it right. I think I did it. Yeah, so it's already deployed. Cool. So we can go then look at the projects, we can look at diabetes, and we can see which ones did well, why they scored, and we can go and look at which ones were deployed. So any questions at this point, kind of to SQL or ML in SQL, how it works? Go ahead. That's okay. So this is called Postgres ML, and this particular UI you're looking at is like their own UI to use their tables, and it's creating an experience. Yes. Yep. And then I've added the extension. Mhm.
Do these things run in parallel? How does that work?
Like from the,
Because you got 500 like data points.
yeah, it's not a lot. Mm-hmm. Yeah. So, I mean, at that point, they show some other papers in here. I could point you to them. They talk about how they balance. Essentially, they built their own thing called PG-CAT that I think holds these models and can be used as like almost like PG bouncer. So you can put it in front and hold models more closely. So the truth is, I haven't run this on like a massive scale. It's been more of a like, this is fascinating. I want to play with it. But I can show you those links for later. Go ahead. Yeah, so from what I understand, I can actually pull it up right here. This is the code. Of course, the compiler guy's like, shut up and show me the code, you know? But if you look under here, so this is the PGML extension. I think it's under the source. And what you can see is they have these bindings in here to different libraries. And then they use Rust because it's cool. And they wrote their own XGBoost in Rust, a binding. And then they will essentially like pull it into the, was that your question? I'm sorry. Cool. I have no idea. So sorry, you'd have to experiment.
Theoretically, yeah, it's gonna use the same memory, but like, you probably could do something like have this running on a separate schema or do some different manipulation that would allow for it to not affect different kinds of queries, but like, generally speaking, when I do anything, if I have any kind of database instance that has latency requirements, basically anything I call production, I don't want anybody running manual queries against, so I would want to have some kind of replica or side database copy even that this would be running on, so it wouldn't affect any of the latency that I have on the other side.
Yep. Definitely there's performance problem. Could be performance. Go ahead.
And like, so for example, and I was looking at this out of curiosity because we're also
Yeah.
that like PVM, like if you look at the code, it's like pretty simple. It'll just like collect that all into a data or like collect it all into a like PVM data set and create it. So just like kind of a or like a
Handoff. Yeah.
models.
No, I don't think so. And I think that's probably a powerful approach because they don't really want to be messing with that over time. Okay, so go away. Sorry, I have this little like screen share thing that's causing problems. Yeah. Just gonna move my tab so I don't keep running into this same problem. Okay, cool. So moving on, we just predicted diabetes, breast cancer. It's a good, 15 minutes so far, right? We're crushing it. So in here, it also talks about how they manage models, and this will show you a little bit more of how it works under the hood. So you can come into here and you can see like there's different ways of choosing how to promote models. I think that was your question from before. You can say like, what strategy do you want to use to deploy the best score? You can issue rollbacks. So I didn't do the handwritten digit. Let me go run that one really quick. So I'll just go into here and I'll just run all of them. So this is the MNIST, like predicting the digits from people when they're writing like zip codes. You can see they've kind of turned it into like an array, multi-dimensional array. Stuck it in here. And then you can predict it. They ran the kitchen sink at it. They did all the different models. And then they even did the one where it will try to go across all of the different potential tunings of an SVM once they saw the SVM as being the best model. And that shows you what the model metrics are. So you can see accuracy, F1, fit time, different things that are specific to the model. So now as I go back to the notebook section, managing your models, we can see that we can like choose to promote a specific model based on the best score. And so what it will do is say that's the SVM. And so it deployed that one. We can also try to roll it back and it will say rolled back SVM. So I don't know what that means, to be honest. But yeah, there's like a whole schema you can see inside of here. So that's ML in SQL demo. Let's go ahead and move on. So what I wanted to do is spend a little bit of time having people look at the different ML in SQL options. So who here uses Redshift? Anybody? No? Okay. What about BigQuery? Any BigQuery? Okay, so BigQuery has an ML library built into it. I believe that they do something very similar for like simple regression and classification models. But once it gets intense, I think they hand that off to their own internal data tools. Sorry, I don't know Google Cloud as much. What about I know there's like, so Madlib was a project that I was watching and was really interested in. It's like a Postgres or Greenplum, but I think that kind of died. So I don't know anybody that uses that one. There's a Heatwave, which is if you take MySQL and put it into Oracle, I think they have this type of stuff as well. available, and SQL Server. Does anybody know SQL Server, what they have available? Do they have something similar? I think you can run Python in it, so you can just like,
So, but they're not.
Yeah.
I'm just kidding, you might be able to.
yeah.
Any guesses as to whether this all works in the cloud if you're running on one of these big databases that emulates Postgres?
Yeah, I think you'll have to check that. That's one of the downsides of this approach, right? That we would get into. Go ahead, Joe.
What do you mean, Postgres? Like,
The library, the extension you showed, is there one?
Yeah, there's lots. There's actually three competing three data companies.
You're similar to this one.
Yeah, there's one like Bloom or something. Yeah, the most recent one is actually huge, like a farm diagram. And it was pretty efficient. There's one in graph, one in plot.
Nice.
More like an extension.
Yeah, you're good. And they're open source and free. So have fun.
Cool.
Unless you're in a cloud provider, it's kind of like, when are you releasing this?
Yeah.
Google gonna have a great extension.
Yeah.
They have it on their Postgres, but they limit the extension you can add to Postgres, so it's like, yeah, so good luck.
Mhm. Cool. So, yeah, we're going to kind of go into now. We've talked about it. We've explained the problems. We've created a new awesome world that we all want to live in and do all of our ML inside of SQL. But like, should we do that? And what are our kind of pros and cons? I'm being facetious, obviously, but what do we think? When should we use something like this? Any thoughts from the group? Go ahead.
Assume that this is for
Once you have the model, you could hook up any language from an API to hit that Postgres and make the,
so it does have, you could set up a server on it? Or do you have to port the model to the server?
no, so once you create the model, it stores it in a table essentially, it just serializes it in the table. And then if you had somebody hitting from an outside API with like a request, you could look up and query just like I was doing in that one array statement. You could produce the prediction and return it right there. And supposedly you can do up to millions on this one if you scale it and do certain things. So I think for batch, it's great though, if the data's there and you run the inference and then you want to put it right back in there, it saves this whole trip way out into Python land and then back to the database. Any other thoughts on when you would want to use it? Because this is just a tool. I don't think it works for everything. So some other things that kind of came to me, obviously we're using tabular data. So if you ever do things with images, I'm looking at it's Isla, right? It's probably not going to be great for images. Any like semi-structured data, it might be hard. You could probably do it querying through the JSON if you wanted. I think it's for simple models, regression, classification, maybe clustering, decomposition type problems where you just want to look at the data really quickly and you don't want to set up the whole infrastructure around serving a whole model. And I think you also need some SQL expertise to be able to pull this off. Do you have a question?
It just occurred to me, as you were showing your, I have no knowledge of, machine learning at all, but.
Oh, okay.
But the fact that you first went through and tried to choose a good algorithm and then tried to find, optimized parameters, might you not find that after you've retuned them, that the different algorithm wins?
Yeah, I think you could. And I think you could probably run all of those really quickly and efficiently just on the database without needing to put them everywhere. Obviously, there are models and algorithms that will not work in this particular case, and they'll not have the right performance. So you may need to pull them out. Go ahead. A tool call, like an agent tool? Is that what you meant?
I don't believe in agents, I think they're gonna be the death of us.
Got some doomers over here. No, I'm just kidding. No, I could see certain things. I mean, it's just a database call. So if tools can do that, then yeah. All right. So when should we not use it? Kind of the other side, right? Like databases that can't support extensions, complex models, unstructured data. If you have a lot of Python expertise, maybe don't use this. Um, so what are some pros of this approach? Anybody see any pros? What'd you say? The suits can use it. There you go. Awesome. Yeah. So yeah, so moving the data costs money. And so this, you wouldn't have to move it.
You don't want your data going, having data leakage all over your.
Yeah. And as I've been trying to think of when to use it, it kind of feels like it's like a lot of things. There's the 80%, like if I can get a quick model that gets me 80% of the way there, but I could show there's actually some value in the data, maybe then we put it into the Python environment and run the whole shebang. But this might be a quick iterations, like rapid model development type of tool. And maybe, I don't know, ML ops. Yeah.
Get it to work in the cloud, egress from the cloud is mighty expensive.
Hmm. Yeah.
Efficient inference, like if you have very tight inference requirements, then you can do it on the data.
Yeah. Can you explain that a little more? I don't think I got it.
Yeah, so, like, there are some cases where you have like very tight, like maybe you need like sub-second,
Mhm.
sub-third.
Yeah.
Second sort of like inference, requirements, you're doing inference on like very large data sets.
Yeah.
In that case, like even beyond the egress part, right? Even if you have the inference server,
Mhm.
databases are built to be able to do transformations very quickly on even their like databases that are moving with like their UDF stuff forward, which a lot of these things are implemented through. So like as an example, there's a company which has done like extensions to using like data fusion
Hmm.
as like a transfer layer and using their binding to like really fast.
Oh, cool. Nice. That's awesome. Yeah. So cons, anybody else see cons on this one? I think we've kind of beat this one, but yeah, you're going to need to know SQL and it could be hard to debug these things, right? You're kind of saying we don't know the library, we don't care to know the library, we're just going to throw it at it, but you can't really get under the hood and see what's going on. So
That's data running in that as well. Like,
Oh, wow, that's like, I thought the wrong.
$2 million worry, anybody?
yeah, cool. So yeah, that's the end of my, oh, sorry, go ahead. Yeah.
Like some of the things that sometimes it doesn't scale that well because for like ML specific workloads, it's just not as well as referenceable. Or you do it through like the extension, but like the handoff there, like there's still there.
Mhm.
So you have like
You're putting it somewhere else.
sorry?
You're putting the handoff somewhere else, putting it down a layer.
There and trying to make it fast, but it's still,
Mhm.
there's still a handoff compared to using like a dedicated training hardware or like training.
For sure. Yeah, go ahead. Oh,
Anecdotally with BigQuery is that, well, for ages, but,
mhm,
you look at the usage pattern, most of which are going for text.
mhm,
A lot more about knots. Plus,
Mhm.
the often we have, less than a check is pretty expensive.
okay. Yeah,
Just to prove like you're talking about.
mhm,
But it made it broad.
yeah, yep,
Last company. It's
mhm,
not a good model.
okay.
So there's a company.
Oh, I didn't see one in here. This is a very new project. I think it's still developing pretty quickly, but I mean, and I don't know a lot about like the scalability and running it in production, so you guys would have to check all on that. But I just wanted to kind of do it as here's a thought. Like maybe we've taken too many steps in certain ways, and there's a simple solution, and we could try it, and then when we need to iterate to a more complex solution.
I agree with that comment.
Mhm.
I think, at a certain point, the number of data points, like it's not called parameters, are there? How big you're training on matters.
Hmm.
And it's like.
Yep.
If you're doing a lot of experimentation and trying to experiment on small different things, I think Postgres, like dumping things into a Postgres database would be fantastic. But if you've got, billions of parameters, like you're just sitting there like,
Yeah.
why? But can I do something to make it more efficient? And that's what software is for.
Yep.
So I think there's a lot of benefits for experimentation with this.
Mhm.
Because you can immediately dive into the data and see what's weird with the data at the same time that you're trying to train your models, which I think is super beneficial. But yeah, I don't know. I don't think I think scale's gonna kill you every time.
Yeah. It's
Not that
hard.
Postgres can't handle everything.
Yeah.
It can, but whatever.
Cool. Go ahead.
I think you were alluding to this, but, after you train it, if you were training it in a different environment,
Mm-hmm.
it's now moving to a different environment. You now have a serialized model.
Yep.
That Postgres database, now you need to figure out how to update another environment or export that serialized model.
Mm-hmm.
Do you know by chance if there's better ideas?
Yeah. Onyx is one. Yeah.
Onyx is fabulous.
I love one word answer.
Onyx, it's ONNX, not Onyx like the Pokemon. Which
Yeah.
I want to sell it, so.
Yeah. Cool. Well, thank you guys so much for coming. I hope it was interesting or challenging.